Hey, what's up, you amazing hackers? Welcome to the OWASP Top 10 course. Now, it's very well known by almost every ethical hacker out there. There are some good reasons for it. It's the top 10 most common vulnerabilities out there in 2017. Now, this list is a little bit old, but that doesn't mean it's less valuable. Let's look at what's in it, shall we? So the top 10 basically consists of the following vulnerabilities. You have injection, broken authentication, sensitive data exposure, XXT, broken access control, security misconfigurations, cross-site scripting, insecure deserialization, using components with known vulnerabilities in them, and insufficient logging and monitoring. Oh my god, guys, that is a wild ride of different vulnerabilities. They talk about anything from insecure deserialization to broken access control, guys. That is a wide range of stuff, and of course there's a wide range of testing methods as well, and also development implementation methods for all of these. Now, there's a little bit of a difference between the different types of vulnerabilities as well, as some are very easy to spot and some are very hard to spot, maybe even almost impossible, but we'll get more into that later. First of all, who am I? My name is Wesley. You guys might know me as the cross-site scripting rat. I'm an avid ethical hacker. I love doing it, guys. It's my passion. As a day job, I'm a QA engineer. That'll be important later on. I've been training people for quite a while. It started out with basic JMeter trainings. I followed the training. I was like, I can do this. So I created a basic JMeter training for the company that I was working for. Then next up, I basically created the advanced method. Then I went to Paris to get my expert certification in Neoload after getting my professional certification, of course. So with this expert certification, I was allowed to teach the Neoload certification. And that was a 3-day course. Yes, you guys heard me right. 3 days of 8 hours of teaching. It can get quite tiring, but there's quite a lot of information in there. There's everything from A to Z in there. So when I look at that, of course, I have to know it very well. I have to study it properly. It took me quite a while to get that certification, and I'm quite proud of that. So after that job, I moved on to another job. The training stopped there for a while, but that's when my hacking career started. And that's when I started giving one-on-one conversations to guys like you, people who wanted to learn, and I taught them programming, basically taught them PHP, taught them Python, everything they wanted to know. And I really had this craving, I really wanted something more. So ethical hacking was my thing. Got my OSCP. I started teaching people how they could hack. Now, that's a really cool way of going about things because I love doing one-on-one teachings. But of course, one-on-one teachings, it only gets you so far. You can only teach one person at a time. It's not like I can teach 50 people or anything. So basically, that's how I went about it. I started with very, very low numbers. I started one-on-one, then I moved on to some bigger security training courses. It all started with an Android course. And in that Android course, I'm going to be super honest with you guys. I copied some screenshots over from a Medium article instead of executing the commands myself. That was a terrible mistake. I should not have done that, period. So I started out with that as a test, sort of like a test if I could create a course, if people wanted to follow my courses. And the Android course did quite well. I opened it up. There was quite a controversy because I copied those images, rightfully so. I should never have done that. I should have executed my own commands. But all of that was over. I made my course free forever. The Android course is free. Now we are up to here, and I've created several courses up to this point. Let's get a little bit into my background, shall we? So basically, it was like my goal to get into the Integrity Top 20, and that's what I did. So it started out with HackerOne. That's where I started. I saw all of these big bug bounties, and I saw the pen testers in my company, and I was like, oh my god, guys, I can do this as well. So I was like, oh, let's get some bug bounties going on. But it's of course not that easy. I reported some crap vulnerabilities, and every hunter will probably report some bad vulnerabilities, especially in the beginning. Now, the problem was that I reported several bad vulnerabilities in a row and one that was a duplicate. So that didn't count to up my karma very much. It was just a duplicate. I had negative karma at that point, so I couldn't report to my favorite program anymore, which was a real shame because that's where I found the cross-site scripting, and I was sure there was more to be found there. So that's when I moved on to integrity. There, in a very short span of about 3 months, I reported 25-30 bucks. That made me a few extra monthly salaries, and I really appreciated that money, of course. But I have to admit, of course, I am no Jason Haddix. Of course, I am no Nahum Sek. I am not like one of these big names in the industry. But that doesn't matter because, guys, what I've done is I've created my own methodology. Where other people are using their tool belts, I use this, my brain. It's very important for me to hunt for myself with my own manual interactions with the website. It's very important to me because if you use automation, automation misses a lot, and a lot of people don't know how to properly set up their automation either, which is going to make the problem worse. So, in my opinion, I started out with my own path. I started walking my own path. It started out really easy. I went from cross-site scripting to IDOR to broken access control. Reported everything that I could find. Still reported some bad vulnerabilities, but the very nice people at Integrity were very understanding, and they just said, "Hey, this and this and this is what you did wrong." Even up to this day, even recently, I've made a mistake, and it happens. So that's me. That's pretty much all about me to know. This is my job, this is my passion, this is my life. I'm also a QA engineer as a day job where I lead a lot of people. At the moment, it's only 3, but that's not a lot, of course. But for a test lead, it kind of enables me to find where the vulnerabilities are going to be because I know where the bugs are going to be. If I wouldn't know where the bugs were going to be, that would make me a pretty terrible QA engineer, I would think. So anyway, that's a little bit about me. I designed my strategy. I crafted my strategy all around this. I deliver bullshit-free hacking courses that help you put things into a different perspective because I am tired of all of these convoluted descriptions that get me nowhere. I want to have something that's understandable, that's applicable, that's maintainable. So on to the next chapter. Thank you guys again, and I will see you in the next one. Bye. On to injections, amazing hacker. Welcome to the next chapter. Now, when OWASP talks about injection flaws, they are pretty much referring to flaws that allow from anything ranging from very low impact issues like HTML injection, which is possible, to very critical bugs like, for example, SQL injections, which allowed for the dropping of tables. Basically, anything that can be injected is what's meant by this particular chapter. LDAP injection, OS command injection, SQL injection, HTML injection, whatever your mind can come up with that ends with injection. So all of these vulnerabilities have one thing in common, and that's their root cause. This all happens because developers, they pass unsanitized data from the user to an interpreter. So guys, if you're a developer, make sure that you never trust user data. Always sanitize it. Now, if you're a developer, you've probably written a query like select star from products where text like and then a % and then maybe you've gotten a get variable called q where to include. Now, if you guys will take the PDFs, in the PDFs you will see this example, and this innocent looking line of code can mess up a lot if we don't sanitize user input properly. If the user can enter any input they want into here, it's very likely that they can just enter what we have here, like a double quote, I think. And in this case, it's going to be when the double quote is injected, the user might inject their own query. So that's a SQL injection. You guys probably all heard of it. As you can imagine, it's not desirable at all, and it's just not the only type of injection, of course. We'll be going into some more later on, but what I want you to know is that SQL injection is just a smart part of the puzzle, but it's going to more often lead to heavier vulnerabilities than HTML injection, for example. Now, take that as you will. Think about it for a second. Let's move on to the hacker's point of view for SQL injection. As a hacker, my point of view is going to be, of course, that of trying to rely on the fact that the developer will need to sanitize all of my data, all of it. If teachers forget one point, I might have a possible entry point. And that's why I'm going to test every single parameter that I see. It's very, very important. And there are two ways to test, of course, because you can test for SQL injection, but you can also test for blind SQL injection. That kind of complicates matters as well, because blind SQL injection is where the server will not return any values for us to process. We can only test that by sending a query, which is known to cause a delay, for example, and then we can watch for that delay. If it occurs, we know that it might be vulnerable, but of course repeat that action because you might have a lag spike or whatever, which might cause the response time to go up a little bit. Now, with all of that in mind, test every single parameter for SQL injection. And if you have any bit of suspicion that the database queries are being executed, for example, if you get an error message when you enter a single or a double quote, that might mean that you have a SQL injection. You might need to investigate it further. Now, you might be wondering, okay, SQL injection, how can I do this? Like, where should I look for all of these parameters? Because, guys, one thing you need to know about pen testing is that a lot more parameters might be vulnerable, but in bug bounties, you're going to have to dig very deep to find a vulnerable parameter, just like with everything. So for this vulnerable parameter, you can look basically in the JavaScript files. Any hidden form fields is suspicious, the Wayback Machine, whatever else you can think of. There's a range of possibilities that you can try and find out what's happening in SQL injection if you find a parameter, of course. Now, from a developer's standpoint, it's a really tough job, guys. SQL injection protection is really tough because not only do you have to sanitize every parameter, but you also have to think about the direct influence of your application. Because, for example, you might be running batch jobs that pick up files, and the content of the files often do need to be sanitized as well, but it's not easy, and it's not easy to think about it. So if you're a developer with third-party applications, it's really important that you look out, and also with your own stuff. It's very, very important that you sanitize every single parameter, every single user input that you can see. I'm going to give you guys an example. I was creating a cross-site scripting challenge, and then that cross-site scripting challenge, really, really basic, not very difficult at all to crack, but something unforeseen happened. People were supposed to crack the description field, but suddenly they started hijacking the ID field because the ID was also reflected in the page. Cannot find ID equals and then the parameter. So every single parameter, even if you think that the user is not going to be controlling it, think twice, think 3 times even, because this is very, very important. We do not want to give anybody any attack surface more than they have to. So if you are a developer, apply the principle of least privileges. If you have a query that needs to read from the database only, then make sure that it's executed by a user that can only read data. And that way, your attacker can never drop any databases. They can never write any data. That's important, really, really important that you keep the principle of least needed privileges. Now, what's also important is the object relationship mapping. As a developer, what you can do is you can create objects and then map those to certain database fields. And then when a query needs to get executed, the query will happen on a collection of data objects and no longer on the database itself. That's a big attack vector for SQLite taken away. You can also use prepared statements for places where you do need to interact with the database directly. You should always use these because prepared statements are just straight up safer than the regular database requests. And anything that you can do, whatever it is, it's so important that you need to sanitize user input. Think about it. User input, sanitization. Always immediately think about user input equals sanitization. Now, over to OS command injection. OS command injection. This particular topic is already covered in some of my other courses. But what OS command injection basically is that when a system is running a shell script, for example, or a PowerShell script, I think it's called PowerShell or something like that on Windows. You guys know what I'm talking about anyway. When those scripts are running on the backend and they rely on data that is being fed in by the user, again, it needs to be sanitized extremely well, because the attacker, what we can do is we can test every single parameter with a list of attack vectors. Every single one of them. We just walk the application manually, then we have a list of particular parameters. We just test every single one of them. And yes, it might take a while, but that's not a big problem. Just let it run. It's not hurting anybody. Run it on a VPS that costs you $5 a month and you're out of your fire, you know? So what we do as hackers is when we try to do command injection, we have a list of attack vectors that we try on every single parameter. You've probably gained that from my previous explanation. But that list is composed of Linux command separators, Windows command separators, Linux commands, Windows commands. All of them are combined, and we look at what specific server we are fighting. Are we fighting a Windows server? Then of course there's no use in executing the Linux commands. So that's how hackers work. They try to find just one single hole and they crawl into it. Now, as for fuzzing lists, it's extremely important that your fuzzing list is good. So we talked about this particular fuzzing list right now for command injection, but whatever you have, it's very, very important that it's good. So thank you very, very much for listening to this chapter. I know it was a little bit ramble, but the next one is going to be a bit shorter, and this one was just one that we had to get out of the way. Thank you very much for watching, and I will see you in the next video. See you soon, amazing hackers. Bye. Hey, what's up, amazing hacker? Welcome back. So, onto broken authentication, shall we? By the way, if you guys are watching this on YouTube, this is part of my course, which will be linked in the description below. Onto the broken authentication part. Broken authentication. It might seem like broken authentication is a bad implementation, has flaws in it, whatever. But broken authentication can be very, very basic. We can even talk about just things like credential stuffing and weak passwords, for example, which is when an attacker will brute force passwords. But guys, I've seen production environment where test is used as a username and password. Please don't do that. Uncle Rat is not happy when he sees that. Now, there's also password recovery options, which you could make a kind of like a risk analysis on, because password recovery options can be pretty bad. Users set up their own password recovery, they set some security questions, and they completely forget about what their security questions are. Later on, a stranger can just go up and talk to them, be a little bit friendly, and bam, he has the password recovery answers that he needs. He recovers the password, and he has an account takeover. So it's kind of like a gray area. Should we try to block this off or not? And a lot of websites are making the risk analysis to not block this off, to leave this possibility open, which is kind of bad for me. I really don't like it. Like, these types of vulnerabilities should be fixed immediately. Now, onto the weak or no encryption of passwords. That's also very important, because say, for example, a hacker steals your database. You don't want that hacker to have access to all of your information. You need to encrypt those passwords and encrypt them fast, because guys, this is how password list gets leaked on the dark web. You have applications that have zero or close to zero encryption of their passwords. Then some hacker comes in, they hack the whole thing, and then suddenly, bam, you have a huge ass problem, because they stole all of your data, they have all of the passwords. And the biggest problem isn't that the passwords are compromised on your website. The biggest problem is that you're going to have to mail your customer, please change your password as well. Very important. So, on to the next one, multi-factor authentication. Multi-factor authentication, very, very important, this one, that it's done correctly. Now, what do I mean by that? You can test several things with multi-factor authentication. A little bit of background information. It's when you log in and you get that annoying pop-up, please enter your authenticator number or whatever. It might be annoying, but it's extremely effective because the hacker will not only have to hack the machine, they will also have to hack the mobile device for the target, which is going to be a lot more difficult than just trying to hack the machine. Now, onto the session ID, it really does happen, and I'm so afraid to say this, but companies still use HTTP, for example, whereas HTTPS exists. Now, the problem with HTTP is that if there is a man-in-the-middle attack, which is where a hacker will actually try to hack the network, he will try to intercept all of the traffic, he will analyze it, and he will pass it on. So that's a man-in-the-middle attack. And in case of a man-in-the-middle attack, like this particular vulnerability, guys, please just use HTTPS. Sometimes session IDs are sent over URLs. It's URL-based authentication. You guys know that by now as well. URL-based authentication is something that happens. You can have session IDs that are passed in the URL. For example, look at AWS. They use it all of the time, but the thing is, it's going to be extremely hard to brute force those. So as for the sessions IDs, passing them into the URL is not a huge problem, unless you use HTTPS, of course, because then you are always vulnerable to a man-in-the-middle attack, and that's not good, of course, we don't want that. Now, as for sessions, it's really important that we talk a little bit about how sessions are handled by the server. Sometimes a developer will configure their session handling wrong, and it can lead to disastrous consequences, guys. I've seen some things in production that will make you cry. So sessions, they might not get invalidated after logging out. Don't report this as a bug bounty hunter. Report it as a pen tester. Very important, because sessions not invalidating when logging out, that's not a real vulnerability. There's no real impact in it. So I wouldn't report it, but it's up to you. I wouldn't report it because I know that it's going to be refused 90% of the time. And I know what you're thinking, Uncle Red. There's a HackerOne activity on this specific vulnerability. But guys, those HackerOne reports, they're all good and fine and dandy, but sometimes HackerOne reports get rewarded for things they shouldn't get rewarded for. So you shouldn't use HackerOne reports as your only source. Try to find multiple sources. A little bit of a sidetrack there. It also happens, for example, that sessions do not invalidate soon enough. Like, for example, if a session lasts forever, if I can create my session right now, come back tomorrow, come back in a week, come back in 2 weeks, and I have the exact same session, that's also extremely bad. If an attacker ever gets a hold of that session ID, if it's never changing, the attacker is going to have the account take over forever. So very important that you invalidate your tokens properly. Now, as for the sessions ID being too predictable, there's a cool burp suite extension. No, it's built into the default burp suite. Now, which will look at the entropy of your session IDs. It will ask you to display the actions, to program a little bit, and then it will request a few thousand, tens of thousands, even hundreds of thousands URLs for those specific session IDs. And that's like, for, let me see real quick. This is one of the most useful tools that I can think of. So for that entropy, you will have to learn a little bit about what entropy means, how it's used, and how it can be used to predict session identifiers. But there's a pretty useful tool in Burp Suite, and I freaking love it. Now, session IDs not getting invalidated after a period of activity is also very important. It's the same as the first topic that we talked over. Session IDs should be validated at logout, of course, but also if the user is not doing anything for 10, 15, 20 minutes. That's also very important. Now, if you're a developer, I cannot make your system completely secure. Nobody can, but I can give you some pointers. So whenever possible, try to implement multi-factor authentication and do it well. You can have multi-factor authentication, which is what I'm going to say earlier. You can have multi-factor authentication where, for example, The server responds with a 200 OK status code and displays a website, even though the multi-factor authentication is not filled in correctly. It might not be filled in at all, it might be filled in with just a 1, it might be filled in with the same like structure. That's like very important for the multi-factor authentication. Now, it's also important that you change any default passwords. If you have a new toy, if you have a new server, whatever, and it has a default password, change it. And don't use weak credentials. Please don't make me see admin or test again. I never want to see those again. I mean it, I'm serious. So you should always keep in mind that the user can also not enter a weak password. If the user can enter 123 as a password, it's like very loose, but the attacker is going to be very easy to guess that thing. But it's like a very fine balance that you have to walk as well. Because of course, if your users are going to have to enter a very long and complicated password, they're going to complain a lot. Oh no, I have to enter my password again and again and again every single day. So that's like for the weak password stuff, make sure that the user cannot enter those weak passwords, but make sure that the user is also not going to complain. I know that's extremely difficult. I've been in this situation. So talk to the users, talk about what they need and how they want their passwords to be made, and maybe even a passphrase could be a good idea. For example, use your imagination, let it run wild. I know you can. You're an amazing hacker, and all of us hackers can do that. Now, make also sure that you never show any specific error messages. That's also very important because error messages often contain personal data, they contain audit logs, they contain steps that you have to do to reproduce issues. So very, very important that you never give a specific error message, but always keep it very vague. And when an attacker fails to log in, you should, oh, by the way, about the previous one, you should always include like a UID or something like that, just to make it easier to track. Now, on to the next one. When an attacker fails to log in, you should limit their login attempts by either implementing CAPTCHA and or time out, basically where they cannot try to log in again. This is very important because you don't want people that are going to be spamming and brute forcing your system. Make sure that you either ban them completely forever or just ban them for now. You can do, you know how it works. Also, very important that you should implement a secure server-side session manager and make sure that the session IDs are random enough. Again, back to our previous point, we don't want predictable session IDs. Very important. Now, really important as well is that as a pen tester, you can report defects in this area. These are usually high critical vulnerabilities. It really depends on how this is implemented, if you have access to this, if it's in scope, but this could be a high critical vulnerability for a pen tester. And sometimes they are of low severity. It really depends. You're going to have to judge it a little bit for yourself. Now, really important, make sure that you invalidate your sessions after both logout period of an activity and just maybe after 10 or 30 minutes, force people to get a new token. Now, as in general, we should never allow accounts that perform impactful or sensitive actions like the administrators to log in via front-end systems either, because yes, this is still broken. This is still broken authentication, by the way. Here's proof, but I'll get to my point. It's really best. This will really prevent an attacker from brute forcing their account. If there is no account exposed to the front end, there is nothing for an attacker to brute force. It's really important, but it also brings along again a little bit of extra work because you always have to be connected via VPN. That's very important. Otherwise, the server is not going to respond and going to give you a wrong error code. This is only available internally. Remember. Now, as for the but that was a voice crack. As for the password mechanisms, you should always require a minimum of 8 characters. This is per OWASP, but the passphrase is, for me, it's the very best thing. The longer the passphrase, the better, because it becomes extremely hard to crack. Now, one thing is also true that it becomes very hard to remember. So I use a password manager for that. I know I'm not sponsored by any of them, so I'm not going to call any of them out. It's, if you have any sensitive features, for example, if you're going to change the email address for somebody else, or if you're going to confirm a buy action for somebody else who has already added in their cart or anything like that, that's also like, give me a sec, by the way. All right, there we go again. Sorry, I had a bit of a dry mouth. So as for these vulnerabilities, we really don't want like them to be like these vulnerabilities, if there are vulnerabilities. Of course, I keep seeing these vulnerabilities, but like there might not be any, but still, as an attacker, if somebody leaves their computer unattended, I can go sit on it, I can order items to my address maybe. To prevent this, what you should do, and this is just a security recommendation, and I suggest, but I really stand behind this security recommendation. Anybody who wants to execute a sensitive function, anything at all, if it's sensitive, then they have to enter their password again. It's as simple as that. Now, as for making our passwords strong, OWASP recommends us a few things. But again, for me, it really depends, and I like passphrases much better than anything. So what OWASP recommends for you creating your password in your database, that you have a maximum input length, because otherwise people are going to throw in massive amounts of strings and your database is going to crash. They're not going to do it via the front end because we are hackers and we do things via an API. Also explicitly set the types of both variables if you're using a language like PHP, for example. This might prevent type confusion attacks, such as magic hashes in PHP. Now, also return, like, sorry, that's not a good bullet point. So it's really important that you do this stuff as a developer to protect yourself a little bit from all of these different broken authentication issues. Now, on to the next one. For TLS, it's for security reasons very important that you enable the TLS. This will prevent any attacker from analyzing the network traffic, of course, that's very important. And your web application and the victim are going to be a lot safer than they were before. So if you can, always enable TLS. Now we're almost there for this chapter, guys, I promise. This last chapter is protecting against automated attacks. Sorry, I keep saying this last chapter. This next bit is protecting against automated attacks, because as you guys know, there might be brute forces and all of that stuff. So it's really important that you rate limit all of your users, and it can be a pretty broad rate limit, like 10 requests per second, 20, but not 100 or 200, because if 10 hackers are going to launch 100 requests at the same time, any server is going to fall flat on its ass. Now, what we need to do is we need to limit the amount of requests a user can make, possibly 2, possibly 10, possibly 50. Implement multi-factor authentication again, and I keep saying that. I know multi-factor authentication, blah, 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 but it's because it is very important. Multi-factor authentication is one of those things that will protect a lot of hackers from victims from hackers. Because even if the hacker can guess or even grab the password of the victim, they still don't have the authenticator. So it's very important there. If a user attempts to log in too often with an incorrect password, you should also log that. Any authentication events that happen that fail, you should always log those. And of course, there's the possibility to implement a CAPTCHA mechanism that will either trigger directly or after a few failed attempts. I'm not a big fan of CAPTCHA, to be honest. You can do it if you'd like, but it's not my forte because it will slow down the users quite a bit. And I get a lot of complaints about these types of things not working. So that's why I just would prefer not working with them. Now, as for the attack itself, it's very important that we log everything and that we investigate it. Because a lot of people will log it, but they won't investigate it. They'll have a log building up, maybe 100 gigabytes by now, and nobody's even told anybody about it. So it's really, really important that you log all of that stuff, that you investigate it, and that you see if there are any patterns which you might have to strengthen or which are used quite a lot. Very, very important there. Now, please, guys, please don't put your passwords on a post-it and put them on the screen. If you do, Uncle Red is coming for you. That is not the intention. Passwords should be in a password manager, protected by a password, and ideally a key file as well. But I don't have one, so I'm just going to do it like this. There's also other authentication methods, of course. We've talked quite a lot about JWT, but there's so many. So feel free to investigate a little bit further and think about more authentication methods and see which ones you can hack and which are vulnerable to which particular CVE in the past. So thank you very, very much for watching this chapter Amazing Hacker. We are already on to the next one, A3. Thank you very much, and I will see you there. Bye, Amazing Hacker. See you later. Alright, Amazing Hackers, it's time that we move on to the next chapter, A3 2017, Sensitive Data Exposure. So it feels like this is a very mysterious topic. There's been a lot of people wondering, what exactly do you mean by sensitive data exposure? Because there can be so much vulnerable stuff exposed. For example, API key disclosed in JavaScript files. But that's not the only thing. And not every API key in a JavaScript file is supposed to be private, some are supposed to be public. So it's really important that you understand what you have in front of you and always understand the context as well, so that you can work a little bit with it. Now, some API keys, they are supposed to be used by XHR requests, for example, and that can be public when you do, for example, a Google Maps request. That key has to be public, it can't be private. So some of these sensitive data exposures that some people think are sensitive data exposures are actually not. They might be just public data being exposed, and people are actually disappointed when those reports get turned down. But I want you to realize that it's very important that this can happen, and it's also important to know that you can make mistakes. That's something that everybody can do. Everybody makes mistakes. It's as simple as that. I just made one the other day. So basically, you might be wondering, how do sensitive data exposures occur? Well, there's basically several places that we can go looking for sensitive information. It's very important. I'm going to list the ones that I know, but it's important that you guys think a little bit and add the ones that you know as well, because these are just my things, and I want you to do your own thing. I want you to, of course, take this into account, but I also want you to create your own list that adds on to this. So how does it occur? They posted on a monitor with a password. Pretty obvious one. That's sensitive data exposure. Debug information. That's very useful for pen testers, bug bounty hunters. We guys love that. We love debug information. So if your logging is enabled and it's on debug and we are able to access it, thank you very much. Also important, GitHub repositories with either passwords directly committed into the public repository. Other sensitive information might be in there, like API keys. So GitHub can basically be a good place to get an overview as well of your application, because GitHub might contain code that's not actively being used, but that is present on the server. And those are the things we want to look at. Those are the things that are important to us. Twitter might contain some tweets with sensitive information by employees. Just look them up, see what they tweeted. Maybe they've tweeted some bad pictures, some bad screenshots. You might be able to get some IP addresses, Lord knows what. LinkedIn might contain information that should not. The same thing goes as for Twitter. Now, the website itself might also contain configuration files, which might be visible to us as visitors. That's also sensitive information, especially if there are passwords committed into those particular configuration files. There might be IP addresses in there that we need for SSRF. There might be God knows what in there. It's really important that you go through it all. There might even be some comments left by the developers, which will help you quite a lot. It's very important that you take these into account as well, because the developers are the ones who created the program. If they are frustrated by something, they will write a comment about it sometimes, and it's pretty funny, but also pretty useful, because they might say, oh, Jeff, he didn't want to use this, so we had to use this. Well, that's information that we can use. JavaScript files might contain sensitive information. Same thing goes there, keys, API keys, passwords, that kind of stuff. Directory listings are sometimes also exposed. Like, for example, if you go to /index.php, you might go to their website, but if you remove the index.php, you might see every single thing that's on their website. A directory listing is what we call that. That is not secure at all. You need to remove that if you have it, because it allows hackers to get an overview of your website. Now, your website might be secure, but still, an overview of your website is pretty darn good for us. Now, as for physical threats, this is something that a lot of people don't keep into account, but pen testing should also include physical pen testing. I've worked with numerous clients that have offered a physical pen testing package before, and I've been able to just walk in with just normal, like the employees. I went there at 8 a.m. and I pretended like I belonged there, and it's really important. For example, one job, I saw that everybody had to wear a fluo vest and a helmet. So it's really easy to get those fluo vests and a helmet. And it allowed me to walk right into a high security construction zone. My dad is a construction worker, by the way. Really cool. He makes houses all by himself, doesn't have employees. He just plops them down in a few months. Damn, you have a house. Really cool. But that's how you get these really cool construction worker things. Now, it's really also important that these things are cool. These things are really nice to talk about, but it's important to notice that this is bad for your company. You don't want people just walking into high security zones, of course. And it's really, really useful as a pen tester to also offer physical pen testing if possible. I know that in current pandemic times, when I'm recording this, there's a pandemic going on. So in these times, it might be harder to get into a building, but still offer it. You never know. As a bug bounty hunter, it's less useful. You can still try. As a bug bounty hunter, it's pretty useless in my opinion. We're not going to do physical pen testing unless we're asked to do it, of course. Then that's a different thing. Now, as for debug information, it's really important that you know that your debug information can give away quite a lot of your server. For example, you might get a very generic debug error like debug wrong email or password entered. It's very hard to notice what's exactly wrong as the end user, but I might also get an error message saying debug unable to find enumerator value administrator. These enumeration types are possible, admin, user, and reporter. So those kinds of things, if you find those are really, really useful, because the program tells you what you have to do. Thank you very much, program, for doing that for us. Now, that's really, really cool, of course, that you know that debug information is valuable. Go through it, see if you can get any values for key session variables like JWT. You might get a JWT token in the debug information for most servers starting up. There might be host names, credentials for backend component. There might be all sorts of different stuff in debug information, like file directory names. Really useful. File and directory names, of course. And all of these things, sometimes they should be reported by a bug bounty hunter, sometimes not. As a pen tester, you should report all of them. As a bug bounty hunter, you have to judge your impact. As a pen tester, report these kinds of things as informational, unless you've been able to escalate it properly. Then you can report it as a good vulnerability, of course, but at least inform your client there. So get good, guys. Git is like an amazing resource for information disclosure. People often don't realize how big of a rabbit hole GitHub can be. Often the developers that work at our targets will create public repositories. Those are really useful for us. They will create these public repositories, upload their work there, and we can understand how our target works. Those configuration files are really interesting. The code might be interesting, but it's really important to note that things like passwords and all of that stuff, developers have gotten onto us recently. They've gotten a bit smarter and they've started putting passwords and sensitive information into environment variables. So that's a bummer, but yeah, that's something we have to live with, I guess. We'll find other ways to crack that information. Sometimes we might be able to find source code, which is a really good thing because we are bug bounty hunters. Every piece of information helps us. A lot of hunters realize that GitHub is a good source of information, guys, or maybe even privately hosted GitHub instances that are open to the public. That also happens when a company hosts a Git repository or a Git instance themselves. There might also be information involved because people don't know what they're doing. A developer might have committed sensitive information and realized his mistake. But if you committed a fix to remove that data, the commit history will still show that first version with the sensitive information. So go through the current code, but also go through the commit history, of course. Now, all of this is really cool. You also have OSINT by chain linking, Twitter and LinkedIn, for example. A lot of developers will possibly not even realize this, guys, but they might tweet sensitive information, which is, of course, an issue. This might include things like pictures with post-its that contain passwords, maybe just a screenshot of source codes that contain things like credentials, API keys, maybe just URLs which lead to a new endpoint that you did not know about. Even if the developer realizes their mistake, it can often be too late, as Wayback Machine might have already indexed that tweet or might have already indexed that code or whatever. And of course, that is a problem. So you will have to go to Wayback Machine as well. Sorry about that ping, by the way. You will have to go to Wayback Machine as well and remove every single thing that you have there. Any information about the company or the products that is posted on social media should be reported as a pen tester, as informative. We have to mention that if they want to remove it fully, they might have to remove the Wayback Machine entries as well, or the Git commit history. Very important as a pen tester. This is also something that you can use, by the way, to further pivot to other exploits. Usually this is not something that we report, like it's not that big. So for LinkedIn, exactly the same behavior applies. Look at it, see what is posted, look at the screenshots, look at the Wayback Machine, all of that stuff. Now for the configurations. Of course, sometimes a misconfiguration can lead to information disclosure as well. You've probably all seen the PHP info page. If it's displayed fully to anyone, it can tell attackers that certain functions are disabled, for example, giving the attacker, again, information that is super vulnerable to us. Another example that can be when the developer leaves the HTTP method trace enabled. This method usually does not lead to information disclosure, but might occasionally lead to leaking of security headers. Those are very important to us as well, of course. As a pen tester, we want to report any misconfiguration we see. Depending on the severity, we will rate the bug accordingly, of course. Sorry about that. But the defect will often be informative or low unless we are able to exploit it further or pivot it to a more impactful issue like RCE because of a misconfiguration. Then, of course, it won't be information disclosure anymore. It will be RTE. As a bug bounty hunter, this information will rarely read to report and can only be reported if we actually exploit something. That's very important to realize. You can only report this stuff as a bug bounty hunter if you find some way to exploit it. Now for the JavaScript comments left by the developers are often a gold mine, guys. It tells you a lot of information about how an application works. There are times when the developer will even leave an API key or credentials in the comments and forget to remove them before committing them. Thank you very much, because these comments are super important to us. We can find them by inspecting the web page. If you have Burp Suite Professional, you can also use the engagement tools, which you can do by right-clicking on our target tab, and then going to sitemap and selecting engagement tools and find comments. So as a pen tester, this is one of the few things that you will rarely report unless we are talking about secrets or credentials, of course. If there's something that's leaked via a comment and it's not very impactful, you will probably not report this. As a bug bounty hunter, these comments can be very useful to us as they lay out how the application works. So it tells a little bit about how we can approach our target. They create a map for us as it be. That's very important. These comments can be usually found in HTML, but also JavaScript at times, and much more. They can be found anywhere. Comment is a comment, and every single programming language has their own comments. So if you find them, they can be super useful. If a third-party connection, which charges us per request, is enabled, we need to rate limit that request as well. For example, if we use Google Maps and Google Maps charges us $10 per 5,000 calls, we need to set a rate limit on there, because otherwise some Dumbo can send us millions of requests and we will be losing a lot of money. The severity can be pretty devastating to a company. For example, a company that is just starting up, they can't handle a 100K bill out of nowhere. That's not possible. So very important to most companies, but always keep in mind that companies can handle this differently. For some, it's important. For some, it's not at all. For most, this will be important. Building a list and checking it twice is very important as well, because some web servers have directory listings enabled by default. That's very fun when that happens. That's, of course, sensitive information exposure, not something you can report as a bug bounty hunter. As a pen tester, you can definitely report this. And this often allows us to find new endpoints without doing much effort. We don't have to do any brute forcing or any of that stuff. Now, for backing up, that's very important, because those directory listings can also find backup files in there. They can sometimes contain source code, SQL code. It's a great source of information, those backup files, for both pen testers and bug bounty hunters. It allows us to pivot further if the information in there is good. Now, as a pen tester, I would report this as a medium-low issue, of course, unless I'm able to elevate my severity. If I am doing that, that's much better. But as a bug bounty hunter, I would only report backup files if you were able to elevate the information disclosure on them. So how do you test for information disclosure? Well, guys, it's really hard to define. There are some general tips that I can give you, but you will have to find your own way into it, and you'll have to get comfortable. It's generally important not to focus too much on one thing, because you might not see some other obvious things which have been hidden by drawing our attention into a rabbit hole. Here in Belgium, we say that we cannot see the forest through the trees anymore. That's basically a saying for we are taking too much on our plate and we cannot even see what we are doing anymore. It's really important that you look everywhere that you can for sensitive data and exposure. Do not just keep it to the topics covered in this article, but if you think of any other places that you can look for sensitive data, definitely add it to your methodology, for sure. Usually you will not find information when you're specifically looking for it, but when you're doing other activities. This means, of course, that you need to be pretty decent at recognizing what sensitive data looks like. This requires some deep understanding of the target you're going to attack. Otherwise, you can't know what is supposed to be sensitive information. You really need to know what you're doing before you can tell what is sensitive information or not. Now, I've left you guys a checklist in the article as well. You can use that for yourself, but you can always add to it as well. Sensitive information disclosure is a bug which rarely reads the report as bug bounty hunter, because we are rarely able to elevate it. As a pen tester, we will report it as informative often. This will lead to the leaking of account information, credentials, API keys, whatever you can think of. But usually information disclosure is used to pivot to something more impactful. So that was my talk about A3 2017. Let's go on to the next one, shall we, amazing hackers? Thank you for watching. See you in the next one. All right, amazing hackers, time for the next one, A4, which is also a really good one because it's XML external entities. I love XML external entities, but let me tell you right now, it's very hard to find in the wild. I know that it's in the OWASP top 10, but I've talked to people who work at bug bounty platforms, and they have confirmed to me that XXCs are rare. They are not very often reported. That being said, it still doesn't hurt to look for them. So let's talk a little bit about what XXCs are, shall we? They're pretty much one of my favorite attack types after cross-site scripting and broken access control, of course. But today we're going to look at all of the possible attack factors. That's important to know, both from the perspective of a pen tester and of a bug bounty hunter. And we're going to look how you can defend your application against XXC attacks. It's not simple, it's really not. So I hope that anybody who's looking at this will take this seriously and will actually defend their application properly, especially against XXE. Now, as for blind XXE, before we start about XXE, we need to talk about blind XXE. It's really important that you know this. So blind, the name says it all, you don't have any feedback. So we're looking for blind XXE 90% of the time over regular XXE. Why is this? Because if we look for blind XXE, we're automatically testing for normal XXE. So this will ensure that we'll not miss any vulnerabilities if we're testing for the blind variant. So blind XXE, you probably know what it is by now. How do we perform it? Well, basically, we're going to perform an XXE attack that's going to trigger an out-of-band service request to our own out-of-band server. For example, the Burp Suite collaborator client. We're going to make the target server make an HTTP call to our Burp collaborator client, for example, or any out-of-band server that we have. So let's talk a little bit about what XXE really is. We've talked about it already for a little bit. It's XML external entities. Everywhere that there's an XML processor working in the background, XXE can be a problem if not configured correctly. An XML processor that will take in any XML file, and I'm saying XML file, but this can be anything. Later, we'll go more into that. And by default, they will allow for external entities to be included. Now, these entities can be anything ranging from system commands like ls, maybe even a reverse shell, to file inclusions like HT shadow and all that stuff. The good thing is that if we do find an XXE attack, it doesn't matter if we are a pen tester or a bug bounty hunter. These severities are often very, at least medium, if you can exploit them, of course. So if you can find any files on the system, for example, you might even get higher. If you can execute commands, you get a higher vulnerability. So it really depends on what you can do here. Just make sure that you don't forget to prove your impact. You really don't want to lose all of your work because you didn't prove any impact. It's super important. Triagers might deny you your bounty because they say there's no impact proven here. Really important that you prove your impact, because by the time you might be retesting it, they might have fixed it already. So most people know what a conventional XML file looks like. We can import this XML file into our applications, and then the XML processor goes to work. But you don't really see much XML out there anymore. That's why XXE is kind of surprising to be in the OWASP top 10. But it doesn't mean that XXE is gone at all. No, it's coming back in different forms, because XXE can be a lot of things. Let's talk about them, shall we? Let's first dive into XXE via SVG. I don't know if you know this, guys, but SVG is basically like an image type. And in that image, you can display XXE attacks, or you can display, it doesn't really matter what you display. You can do cross-site scripting attacks via that sorry, I'm kind of going on. That's not true. It's late here. So what an SVG is, in essence, is it's basically just an XML file. We can include external entities in here, and in those external entities, remember guys, we're looking for blind cross-site scripting. We're going to try and make a callback to our own web server. Now, remember that sometimes callbacks to our web servers may be blocked. That's what they call egress filtering. Outgoing traffic might be filtered. Now, as you guys have the PDF open in the course, under XXE via SVG, you can see how we include such an XXE into our system, into our XML. So we basically define the entity, and then we say what it has to do. We call it by system, and then we insert it somewhere into our XML, into our SVG at this point. Something that's very important to note is if you are talking about an XML and you're doing the same thing that you're doing here, you have to test like every single field that you can see. You have to test, if you guys see the what is XXE, you see a piece of code there, you will have to test the to field, you will have to test the from field, you will have to test the header, the body, you will have to test every single field, because the developers will have to secure every single field as well. Now, sometimes attacking a target means getting creative, like, for example, XXE that can happen via PDF. Now, if you guys have the course in front of you, this is a trick that I found on Hack Tricks, really good. You can find a link in the course, and this trick is freaking amazing. So you can basically, whenever the system accepts a PDF, we might be able to change that text string to XML input if it accepts it. Sometimes it will accept it, the system, and it will basically process our XML input. We can then go ahead and add external entities in there, and then of course we need to call them as well. In the course, there is an example. Now, JSON to XXC, what you guys have probably asked me 1,000 times is, okay, I see JSON files here now. I see JSON responses. How do I handle this? Because XXC is something XML related, and JSON is supposed to be better than XML a little bit. It's replacing XML. And basically, if you just change the content type header from application JSON to application XML, it might accept it as server, our target. And if it does that, we can again insert our attack vector in there. Again, an example will be in the course. Now, SOAP is also XML based. Those of you who know SOAP, well, not the soap that you use for washing, of course. Those of you who know SOAP that you use to go and make a call, a web call, simple object access protocol, it's basically in XML as well. So we can do the same thing here. We can test for XXC, SQL injection, cross-site scripting, all of those things. So now how do we exploit it? Because XXC is a real cool vulnerability, but let's say we find one, how do we exploit it? We have several options here. We can either grab files from the system, which is very useful. Sometimes you might want to do that. You just include your entity, you say system and then file // then you enter your path, then you include that same entity, and then it will show up. Now, some really cool tricks as well that I've seen again from Hack Tricks is that you can, for example, sometimes it's prohibited or sometimes XXC sometimes will just not work. It can be overcome by using error messages as well. We'll trigger an error message, a non-existing file, for example, but we will add an existing file in there, and then we will show the error log because the errors are often not checked as properly by WASP and all of that stuff. So executing commands is also possible. Expect // is the command that you need for the XXC there. There are several different ways to execute XXC, and I would definitely recommend that you go and look for them yourself as well. You can also execute SSRF via XXC, again, making a callback to our own server or making a callback to an internal system. That would be a medium-high priority if that system is any sensitive information or contains any sensitive information. We can also do a callback to an internal server somewhere with a port open that we cannot access normally. For the admin page, for example, we can do this is also pretty cool. You can basically link back to the same server on a different port, but that port might only be accessible from the inside of the application. Well, then we can link back to that specific port. Now, there's many different ways you can exploit XXC, as you guys have seen. Blind XXC is also a pretty important thing to understand. Now, I've said in the beginning that we're always testing for blind XXC, and I kind of lied because if you guys already heard, the egress filtering is a problem. Now, the egress filtering might be a problem, but it's better than testing for non-blind XXC, I think, because I think you're missing quite a lot of XXC out there. Now, it's only my opinion, of course, but that's something that you should keep in mind probably. Now, for executing a denial of service attack, that's also possible. These XML entity processors are not very fast at all. So if you feed them like a ton of variables and you let it resolve, it's going to take a while and it's going to block out your entire application in some cases. Definitely not all of them. So there are also some bypasses for this. Sometimes our original XXC attack is filtered. We might need a bypass. One thing we can do is do it in base64, for example. We can create an entity, we can call system, and we can call data // to get a, well, /text/plain semicolon space 64 and then a comma, and then the specific base64 text, which might get smuggled past the web application filter because it might not have the steps needed to actually decode this. Remember from the WASP course, if you're in there, of course. So that's a way to get around it. Base64, UTF-7, an example would be trying different encodings. It can still work that way. There are some examples in the course, but there's much more online. I've also included some XXC tools for you guys. Feel free to go over them. There's not that big of a list because XXC is pretty hard to find, of course. You're not going to find it in a 1, 2, 3. So it's very situational. You're manually testing, and it's usually the best way to find bug bounty hunters. Another useful item that I have to share is a document with XXC payloads. I found that online as well. It's going to be in the course again. So how do you prevent all of this? Well, there's basically several things that you can do. You can do a static code analysis, which is basically just reading the code and seeing, okay, I'm reading this code. Does it make sense? Is there any security issues that I see? Just statically without looking at the code. You can also do it dynamically by running your application, which is why I have several machines in here. Actually, if I want to hack something, I actually have to install it on that machine. I know I'm kind of weird on that. I know virtual machines exist. I know Docker exists, but I like my physical machines and my physical devices. I'm kind of strange like that. Now, of course, manual testing is also very important. Our manual testers should be trained to look for XXC entry points, even if they're not that technical, because it's not that big of a deal. You should just have one technical person who takes this XXC thing under their wings. So that's very important. Now, some of the risk factors that you might encounter is if your target processes XML files, if your target allows tainted data in the DTD section of an XML file, if the processor is not made to validate XML with an XSD, if the processor is configured to resolve external entities within the XML files. So all of these things, as a developer, if you have one of these, you should probably fix it. Just a small tip I will give you. You should probably fix that stuff. It's a big risk factor. Some general tips I will leave you with is that it's pretty much, you should avoid XML external entities as your first vulnerability. You should avoid it until you're very comfortable with other vulnerability types, because XXC is extremely hard, and you should start out bug bounties by looking for something that you know. Start low, get a bug, it doesn't matter, subdomain takeover, password forgot, token in plain text, doesn't really matter. Thank you, by the way, Insider PhD, for that information. It was really useful. So what you want to do is you want to make sure that you should avoid uploading XML files, and you should opt for other formats, such as JSON instead. If possible, you should not allow the user to upload SVG files. The risk is pretty much too high, and you have to make sure that whenever you do an XML processing library, and whenever you include that you patch it fully and keep it patched fully. If you have an external library and you don't patch it, issues might still occur. On that same note, make sure you use SOAP 1.2 or higher, because older versions have a vulnerability in them and they're no longer supported. If you use XML, disable external entities and DTD processing. It's not needed anymore in these times. It's strange that it's still enabled by default. If the user can upload an XML file, which you should really try to avoid, make sure the structure is correct. Check it with an XSD file before the send off to the XML processor, and please just enable all of those, like the scanners, enable them, make sure that you have them good and well. Now, use static code analysis tools, go over the code manually, but also use some tools. They're very important, and it will pick up some stuff that the testers have missed. Invest enough money in testing the quality of your product. It's super important, and the safest way to prevent XXC is to disable DTDs. The external entities, basically completely disable them, and it will depend a little bit on the parser. So XXC, wow, what a beast, what a monster. Don't go for this as your first vulnerability. Make sure that you have some better vulnerabilities in mind, like I just said, some super easy vulnerabilities that will get you into private programs, which you so dearly need, because you don't want all of that competition. Thank you very much for your attention, amazing hacker. On to the next one. See you soon. Alright, amazing hackers, onto A5, broken access control, one of my favorites. So broken access control, if you have the PDF in front of you, it's basically just somebody accessing functionality that they shouldn't be able to access. You have several different types of broken access control. You have horizontal broken access control, in which one user will see the data of another user that they're not supposed to be able to see. If an identifier is involved, with 99% of the cases will be, it's going to be called an IDOR, insecure direct object reference. So what's really important for an IDOR, because I've been teaching you guys quite a lot about IDORs, but one thing you've been missing all along, and that's my fault because I haven't been teaching you this properly, IDORs need an identifier somewhere in the request. So I've been teaching you guys how to juggle with these session IDs and authorize and all of that stuff, but IDORs need a identifier in them. So some background information: you will have first level IDORs and second level IDORs. Now, what is a second level IDOR? First of all, a first level IDOR is basically just a user directly going to a URL or whatever and accessing functionality they shouldn't be able to access. Now, sometimes that might be blocked off, but there might be other system components which might be able to access those objects, for example, invoices. There might be if there's a sales trainee, he's going to be able to see the quotes, but he should never be able to see the invoices, for example. So he'll do a get to documents.php question mark ID equals 1234, going to get denied because the invoices is not allowed. So what's going to happen here is that there might be a different system, for example, a system that generates the documents for those invoices, and the sales trainee might have access to that document generation system. And he might still be able to see the invoices because they're also documents. That's an example of a second order IDOR. It's going to be something which is not directly calling the functionality in question, but it's going to call it via another route. It's going to make a different system make the call for our attacker, for us. So we're going to make the system make a call for us, and the system, that's something people often don't think about. Another example I can give you guys is if you cannot enter other people's products, if you cannot edit them, you might be able to upload a Excel sheet, and in that Excel sheet you might have the same identifier as the other person's product, and bam, it might have been overwritten. So very important that you look out for those kinds of things. If you're a developer or a manager or even tester, you have to be very aware of other systems accessing identified objects that they shouldn't have. Even can be unidentified objects. Like, for example, if a system can access functionality that a trainee should not be able to access, like printing out a document, a trainee should, by example, never be able to print out documents. That's also going to be with an identifier, but it's about the functionality itself. He just doesn't have access to that functionality. Okay, on to the next part. So let's say you start hunting. What do you do? For me, it's really, really important that I know all of the functionalities that are available to me. I need to know them, and I need to write them down in an Excel sheet because my memory is terrible and I will forget them. I need to write down what each and every single user is allowed to do, and I need to have a good overview of that, because later on I'm going to test for broken access control, and I don't want it to be a hell. I just want to have an Excel sheet that I can check everything on. Because, guys, 99% about bug bounties is just checking different parameters that other people didn't think about yet, like the second order IDORs. Other people didn't think about the different systems accessing the documents there. That's a good example. So another thing we can do is, for example, when we want to cross over a border, you're always asked to show your passport normally, to show that you're authorized to do that action. Like, can I travel over this border or not? You have to show your passport, and that's like sort of like access control, not fully like access control, but you can sort of compare the two. So I've made a little diagram with a user that has their passport is not authenticated, so they're going to be a 403 there. Then they're going to check if the user is authorized to do an action, and then they're going to execute that specific action. So in the case of our person, they're going to see, is that person authenticated? Does he have a passport? Okay, then is that passport valid? Is it authorized to go on? And then if it is, then you get a 200 back. If any of the checks fail, you get blocked off. That's the same thing for access control, basically. So our checklist so far is going to be, well, you guys can see it in the PDF, but all of these different broken access control things that we have to check. There's a lot of them, and I told you guys this before, bug bounties is 99% about checking everything, pen testing as well. Make sure that you cover all of your bases. The more vulnerabilities you get out, the happier your customer is going to be. If you're a manager or a developer, you can test these things for yourself, or you can have your functional testers go through them. But you have to have the help of a developer if you're not very technical, of course. Now, it's always better to prevent than to cure, of course. So as you might be able to see, we have quite a lot of things that we can test for, and we're not even done yet. Really, guys, it's really hard to describe every single situation into extreme detail. We can give some details, a general overview to prevent these types of vulnerabilities, but we have to go very deep into the testing aspect after this as well. So we want to deny access to any resources by default and only allow access on those resources where it should be accessible. That's the whitelisting principle. I know it's very cumbersome, but it's the most secure one. So take it as a risk analysis thing. Do you want to spend time whitelisting everything that you need, or do you want to just accept the security risk and move on? You need to create reusable methods for authorization and implement the same method throughout the application. That way you can ensure that the authorization controls are implemented consistently. Sometimes it might happen that different authentication or authorization controls are enabled. That's going to be very confusing, of course, and that might lead to vulnerabilities. Make sure that you disable the directory listings on your web server, guys. It's very, very important. There should be no metadata information available. No Git files, no backup files, nothing of that sort. Only what the customer is supposed to see. Any failed login attempt or even failed attempt at accessing functionality that is not allowed should be logged and appropriately talk to an admin. He should be alerted about all of this stuff. Very important. Alerting is good because logging alone isn't going to cure everything. You still need to check your logs, and there still needs to go an alarm bell ringing. So rate limit your APIs, guys. This is a very important one. I've seen several rate limiting bugs that are popping up all over the place. I know it's a little bug. It's like a P4 in most cases, but it's very good that you seal off all of these holes. Because like I said, in most cases, but it might be a P3, P2, P1, P0 even. So depending on the impact, it's going to differ. Any authorization headers should have a very limited validity. They should be disabled upon logging out of the user. So if a user logs out, any of the authorization headers should be disabled. Now, these are all best practices. Risk analysis, take them as you will. You have to do your own analysis. I can't do that for you. I can give you the facts, and you can do your analysis based on that. So how do we test for this? There are basically a couple of things. You can copy and paste the URL from the high privileged user to the low privileged user. You should get an error. If you don't, then you know that there's something wrong. Now that you can also automate it, you can just copy and paste it into every single field manually, but into every single browser manually, but you will have to, of course, log in with private browser, any normal browser, or you will have to use a container tab like Containerize in Firefox. What we can also do, and that is what a lot of people seem to neglect, is just copy and pasting JavaScript methods. Just go to your high privileged user's website and see what buttons are available and if they have JavaScript methods available behind them. then copy them and paste them into the console of the low privileged user, and you might get information that you're not supposed to be able to see. JavaScript is often ignored, neglected even, but JavaScript is an amazing tool in our arsenal. So we can also do is use authorize or auto repeater to change these headers automatically for us. And then whenever we click through the application, auto repeater is going to send the same request with different authorization headers, and it's automatically going to test lower privileged users that way. We can look at the responses and the results. Those are very important. Now, what you can also do is changing the request method, and this is going to be the last one, because an IDOR might not exist in the get method, but if you right click in Burp Suite and you click on change request method, you might get a post, and that might get accepted by the server. A post method might not be foreseen by the server, so very, very important as well. I know I keep calling everything important. I'm terribly sorry about that, guys. Thank you guys so much for looking and listening to number A5, and we're going to go on to number A6. Thank you guys so much, and I will see you in the next one. Bye, amazing hacker. All right, amazing hacker, welcome back. Time for A6 security misconfigurations. So this name was chosen to be as ambiguous as possible in my opinion, because it can be anything is security misconfiguration. Literally anything, like everything related to configurations. If it's related a little bit to security, you can misconfigure it, and that's something like it's very hard to really make sense of this type of vulnerability and say, okay, this is what you have to look for, but we're going to try it anyway. You guys know us, we are rats, we don't give up. So what might happen is my target vulnerable. You want to test, is there a security misconfiguration? These are the things that you should be looking for. Remember, some of these are to be executed as a pen tester, some of these as a bug bounty hunter. There will be a difference in them, of course. So there might be missing appropriate security hardening across any part of the application stack. Most applications these days consist of complete technical solutions, and issues might arise in any of these components. Now, you need to be a pen tester for this. Unless you have an extremely good overview of all of the components in the system, you can't really test them all. You can't test something you don't have an overview over. Now, when our target uses cloud services, make sure that they configure their authentication and authorization on those cloud services. Some people tend to forget that, and that leads to some funny vulnerabilities where their whole infrastructure is secure, but their extra infrastructure, like Amazon or something like that, is completely open to anything. So if features are enabled that are not being used, make sure you disable them, guys. Very important one, because these can lead to extremely difficult to fix vulnerabilities later on. If you don't fix this soon, so if you don't remove a feature from your production environment, it's going to get integrated more and more and more and more and more. And the problem is, if you have to remove it later on and it's integrated in 7 different places but never used, that's a bit of a problem, I think. And people get scared of removing that file after a while as well, you know. After 6 months, who dares remove a file that they don't know what it does of? Nobody will know what it does anymore. So fix that crap, guys. Some admins are very lazy. They might leave passwords default. They might put in super easy passwords. Whenever this happens, of course, that's also a security mechanism, misconfiguration. So try default passwords, try easy passwords. I found several of these in VDP programs. Our target needs to keep its system and dependencies up to date. That's really important. Besides keeping them up to date, we need to make sure that the components are enabled and configured properly. Configured properly. That's a very hard term, because configured properly says a lot, don't you think? It says that you need to have the correct security configuration, but what does that entail even? Also, if there are any of these settings surrounding security is set to an insecure value, that's what OWASP provides. But what does that really mean? An insecure value, like a easy to guess password, a open port that should not be open. Some of those things are things that I am thinking of when they say misconfiguration. Our target needs to keep its systems up to date. We've already been over that. And if the server does not send security headers or directives, that means that the secure configuration is not set correctly, of course, because we need those security headers. Now, to prevent these types of vulnerabilities, we might implement several mitigations. Now, what we really need to do is we need to set in place some of the automated systems so we can easily deploy a new testing environment that is identical to the production environment in regards to security and configuration. Then we can test that fully, and the development testing except the production environment should ideally be identical with different credentials used in each environment. We need to have a minimum amount of functionality possible enabled. If we don't do that strictly, we are not testing components. So what is important is that we first test our component, and then we move on to the integration part. If your component is not used, you should simply disable it. This includes shadow APIs, by the way, guys, which are APIs that are online, but nobody ever knows they exist. So they might hang around for a while until a hacker like me or you discovers them and maybe abuses them. That's one of your worst case scenarios, I think. We need to also implement a process to do a periodic security review that focuses on cloud storage strategies as well. We need to see if our cloud storage is safe, and a good separation of components with attention to separating tenants if they use the same hardware is very important. Like if I have the same user that logs into the same URL and they all share the same database and all of that stuff, it's important that you keep them apart. Now, what are we hunting for, guys? If you're hunting for this, you're basically, and this is my list, I want you to think about this and I want you to add to this list, because this is just my list, of course. What can we test for? I always test for cloud storage misconfiguration, of course. I test for network infrastructure configuration. I test for application platform configuration. That's also very important. And I test for alternative HTTP method to get, post to get, etc. I also test for the HTTP strict transport security layer, because, for example, if forgotten password sent in plain text is a issue. If you get the token from a plain text generation and other people are able to read that, then that's a problem, of course. Now, testing these types of vulnerabilities is not easy. I also look at the alternative HTTP method. It's basically broken access control, the same thing. I use the Terra as well. And we can use the options HTTP method to find out which HTTP methods we are able to run. Sometimes post might not work, but put might. You never know, just try it. Again, bug bounties is 99% sure that you're just going to have to test every single parameter. I know it's hard work, I know it's tedious, but that's bug bounties. And of course, bug bounties is exciting as well if you can report that vulnerability. But 99% of the time, bug bounty hunters are searching for vulnerabilities. They're not celebrating their victories, believe me. So how do we actually hunt for this? What I do is I do some Google dorking. I look for config files, YAML files, XML files, anything. I use the file type Google Dork for this. And besides that, I also do the exact same thing for GitHub, basically, where we might have some more luck, as usually developers are not as reluctant to push their code to GitHub. So whenever you come across a configuration file, but then it's up to you to find out exactly whatever setting is for, and that setting can be unsafe at times. You just have to Google around, you have to see what's available, like how is this vulnerable, how can we abuse this, for every single thing. That's how I started hacking as well. A little bit of a sidetrack after the end of this, so not going to be any more about the course. Feel free to switch on to X6. If you're hacking, like if you're doing bug bounties, it's this kind of thing, security misconfiguration. There's going to be like, how shall I put this? Unsafe settings are one thing, but whatever you come across, whether it be a new web application firewall, whether it be a new programming technique, whether it be a new vulnerability type, whatever it is you come across, if you have any doubts, you have to Google it. That's how I started as well. I just started Googling everything that I came across, how to hack GraphQL, how to hack this, how to hack that. So that's how I started in bug bounties, and that's how I think a lot of people will have an advantage. Thank you very much for watching A6. I think we should go on to A7, don't you think? See you there, amazing hacker. Bye. All right, welcome back, amazing hackers, onto A7 cross-site scripting. So you guys may have all heard about cross-site scripting, but not a lot of people know what cross-site scripting really entails, in my opinion. So we'll go over that and what cross-site scripting really means, because first of all, we need to know what cross-site scripting is before we can dive deep into it. This is basically a vulnerability that occurs when a developer takes user input but does not sanitize it properly, and then renders it onto the web page. Now, there are several ways that we can sanitize this input. The safest, but also the most restrictive one, seems to be whitelist-based filtering. Whitelist-based filtering is implemented by checking every single piece of user input and only allowing if that user input is only allowing that user input if it is defined on your whitelist. But as you can see, that's very, very cumbersome because you will need to define every single input type that is allowed. Now, of course, that's pattern based. You don't say, oh, this specific sentence is allowed. No, you say when a sentence looks like this, it's allowed. But there's also blacklist based filtering, which is the other way around, which tells the server, oh, this specific input is not allowed. So whatever type of filtering you pick, it's going to depend on what your company's requirements are, of course. Whitelist type filtering takes a lot more time. Blacklist type filtering is a lot more vulnerable, of course. Now, the impact of cross-site scripting can really depend on a couple of factors. First of all, we need to check in which context it's reflected. And this is where a lot of people go wrong. And I've included a part of my cross-site scripting course into the OWASP Top 10 course, because that's where you'll find some real information about the HTML, the specific cross-site scripting contexts where cross-site scripting can occur. Also, it's very important to know that a simple alert isn't going to prove it anymore. It's not going to be enough in these days. You really need to prove your impact. Just an alert, not gonna cut it. What you need to do is steal a cookie, but even stealing a cookie is not going to be very prevalent these days anymore, because most session cookies will have the HTTP only flag set. What we can also do is steal data from the page by just copying it, sending it as a GET request parameter, but that's CSP's job to prevent that. It's going to, like, CSP is properly implemented, it's going to restrict your ability to abstract information from a specific page. So we can also, for example, execute JavaScript functions, but that's sometimes also blocked because, of course, if we can think about it as a hacker, there's going to be a defense for it, like this one, for example. Can we execute sensitive JavaScript functions? In most cases, you'll be able to, but in some cases you won't be, which again, CSP will be responsible, because sometimes the server generates a random alphanumerical string, which you will need to know before you can execute any JavaScript functions. So what's also important for determining the impact is what type of, where are we? Like, are we in the main website? Are we in a child of the main website? Are we in iframe? Are we in a sandbox? Any of those limiting factors is going to be important in determining the impact of our vulnerability type. What context are we working in? Also very important. After all, if we are able to insert data into a hidden input field's attribute value, that might not be as impactful as being able to insert a script tag onto a web page as HTML injection. Now, it really depends, and for this you really have to think, what am I dealing with here? What does the company, what does my target want? Does my target want to know about cross-site scripting in every sense of the word? Does it want to know every single vulnerability type? In that case, you're going to have to report that specific vulnerability, like, for example, the hidden input field and then having an attribute. Then you're going to have to report it. What's also important is, can you steal any data without having to execute dangling markup injection? Because dangling markup injection, that's a sort of limiting factor of cross-site scripting. Now, also important, sometimes it's possible to steal CSRF tokens, which you can then chain. If you can chain any of these vulnerabilities, that's going to definitely increase your impact. If you have self-cross-site scripting, that's kind of messed up, of course, because then your severity is going to be non-existent. It's self-cross-site scripting. But you might be able to chain that by inserting your cross-site scripting attack vector by abusing a CSRF vulnerability. So how to hunt for cross-site scripting is something you might be wondering to yourself, because we have a passive method and an active hunting method. For the passive method, what I'll do is I have a specific attack vector, and if you have the PDF open, you'll see it as well. It's a single quote, double quote, image source equals X, and then a B rat was here. A B tag rat was here. Now this single quote, double quote, I'm trying to break out of the JavaScript context. The single quote, double quote, and then the less than sign is me breaking out of the HTML tag attributes, or at least trying. And the image source equals X and B tags are basically just insertion of random data. If I see a broken image or I see red is here, give me in bold text, then I know that I have a vulnerability. So this I'll enter into every single parameter that I see, into every single field that I see, I will enter this value. And I also do this, for example, into my name when I register for the target that I'm testing, because later on, when the application might use my name, I'm automatically testing for cross-site scripting, since it's gathering this cross-site scripting attack vector. Now, that was my passive hunting. For the active hunting, there was a value when the red is here. Give me that specific value. I'm going to send off to the server, and I'm going to look for what locations that value is reflected into. Might be, for example, the JavaScript file, might be the HTML context, might be the HTML tag attribute. The value might be reflected in DOM and Angular context. There are so many contexts there. I think you get the point by now. It's not just HTML injection. It's really important to know what characters are filtered here, where is my value being reflected. Can we attack the system without using any of those filtered characters? If we can get around the filter for forbidden characters, how our value is reflected, and how we need to attack it. All of these things, we need to do that. We need to look at that to perform an active cross-site scripting attack. As if all that wasn't good enough, the impact of our attack will vary greatly, of course, as well. I went over this in the chapter, what is the impact of cross-site scripting, but this specific hunting, it's going to take you quite a while to find a vulnerability. Don't get me wrong, at least for bug bounty hunters, this is going to take you quite a while to actively find a cross-site scripting vulnerability. It's not as prevalent as people think, but then again, nothing really is. It's never really as prevalent. As a pen tester, you might encounter this a lot more, but that still doesn't mean it's super, super prevalent. Now, for this specific topic, for the types of cross-site scripting, a lot of people have asked me, okay, you have your reflective cross-site scripting, stored cross-site scripting, you have blind cross-site scripting, dumb cross-site scripting, and I purposefully made a mistake there, because blind cross-site scripting is not really a type of cross-site scripting. It's just a type, sorry about that. It's just a type of stored cross-site scripting, basically. And for blind cross-site scripting, what I do is I have an out-of-band server, and I try to make a call to my out-of-band server for that. So that's basically what I do for my cross-site scripting attacks. Now, for cross-site scripting into the account takeover over. This is something really cool. I've outlined a scenario for you guys, which you can go through in the PDF, and it basically shows you how you can actually steal an account using cross-site scripting. And it might not be as hard as you think. You might be thinking, oh, I might be having to write all of this different code, all of this complex code, but it's actually pretty simple. Have a look at it. I'm not going to go too much into detail about it, but it basically comes down to stealing a CSRF token with password reset. I know most password resets require you to enter your current password as well, but sometimes they don't. So I've outlined a scenario for you guys. It's pretty simple to understand. What I want you to do is actually think about some scenarios that this might also be applicable to. Think about some other scenarios which might lead from cross-site scripting into account takeover. As for prevention, you have to make sure that you have a good usage of single origin policy, good usage of CSP headers, that they are set properly, that you do not allow anything from unknown domains. Make sure that you sanitize user input properly, very, very important. And always mark important cookies with the HTTP only flag. Most of you will already be doing that last one, but still, if you haven't already, super valuable information there. More information is going to be in the PDF document, which will give you guys links to each of the things that we talked about in the prevention. And I think it's time that we move on to number 8. I don't know what about you guys, but I think I'll see you in the next one. See you in the next one. Bye. All right, amazing hacker. Hope you're doing well today. Let's talk a bit about insecure deserialization. Because insecure deserialization, it's often seen as a very hard vulnerability type, but it doesn't have to be. In this module, I'm going to look at PHP and Ruby, but of course there are more deserialization processes available. For example, Java, but Java is known to use binary formats, which are much harder to read. So let's start from basics, shall we? So that's why I included PHP and Ruby as well. So let's talk a little bit about the serialization project, because serialization has all been made to basically serve one purpose. The serialization process is there to make complex objects, convert them into a uncomplex string, into something that's very easy to read. For example, a user with the name Carlos and a specific property is logged in equals true might give some serialized data that looks like what's in the PDF. And whenever you see that serialized data, it's very important that you know how and what to attack, of course. Then there's also the deserialization process. That's exactly why, this is where the magic happens. The deserialization process is a very sensitive process. A lot of developers don't know how to implement the proper security checks on it. And ideally, we should just never trust user input. Now, I know we don't live in an ideal world. You're going to have to make a little bit of a risk analysis on this one, or you can just have your website or target tested by a bug bounty hunter like me. So you might be wondering, how do I identify it? I've included some things for you guys in the PDF as well, which you can go through. That's how you can identify these types of vulnerabilities, these insecure deserializations, that is. And you might now be wondering, okay, Uncle Rat, tell us a little bit more about that functional testing, because when we're testing purely functionality, we are basically relying on the fact that we might find one of those serialized objects somewhere that we can manipulate the value of. The Portrigger Labs uses the cookies as an example, but it can also occur in other locations, such as hidden field in a form that might be a serialized object. There are many different locations where this issue might occur. So if we have a look at those Portrigger Labs, we can see some easy PHP examples. If all of these rely on a cookie being set as a serialized PHP object, that's not good. If you can check the cookies, you should find something similar to our example as well in here. But again, it really doesn't have to be cookies. It can be anything. Now, let's move on, because I know that I'm babbling a little bit. What I want you to know is that we have this object injection. It can be implemented in our labs if we really want to. but you need to be really careful with it, because sometimes this can mess up your system. If you install it in a lab and it's vulnerable and you don't interpret this properly, then you might have some issues. So that's it basically for insecure deserialization. It seems hard. What we have is a serialized object. We might be able to manipulate that serialized object, send it off to the server again, and we might be able to pull off responses that we weren't otherwise be able to pull off. Now, it's very important because a lot of people have asked me, Uncle Rat, I don't have this person's social security number or his full name or whatever. Should I still report this vulnerability? And I always say no, just if it's too small, don't report it. Move for the big guns. Maybe report something to get your first items in, but this is not a good item to get in. So thank you very much for watching, everybody. I hope you enjoyed, and I will see you in the next one. Bye, everybody. See you later in the A10. Alright, amazing hackers, welcome back to A9 2017 using components with known vulnerabilities in them. The term components is very broad in this sense. It can either be full piece of software that our target relies on from third parties, such as the SME client for Belgium or the Google Maps client, for example. Those can be components, but it can also be internal components as well. Now, these components can have known vulnerabilities in them. Third-party components, libraries, for example, they might have vulnerabilities in them in specific versions. These issues are extremely hard to fix, as they often rely on the human psyche to be lazy and careless. We often are lazy and careless, especially when it comes to dependencies and keeping things up to date. They have to be fixed, these kind of issues, at the source, because just updating that specific version to the latest one and being up to date again is not going to be enough. These things have to be fixed properly. Somebody has to be informed, like, hey, we have to update everything properly. We have to have a good updating strategy. So you might be wondering, what are we looking for? If our client, in case of a pen testing, or target in case of bug bounties, has a very poor understanding of the dependencies they are using and any nested dependencies in them, they're much more likely to be vulnerable. This is hard to gauge at first, but anything is. It really matters to spend time on your application, and with passing time will come solidifying knowledge and also about the internal workings of your application. Now, these dependencies do include more than just what you might think of in the first place. We are, of course, talking about things that are included in any configuration file of the software, but also of things like any database systems, APIs, and even the operating system itself can be out of date or can be with a known vulnerability in it. These types of vulnerabilities can be found using automated scanners, but we should be very careful not to step outside of our boundaries when we do use these automated scanners and only scan what we are allowed to scan. I always prefer to just do passive scanning with no spidering or any request spidering to speak of, because then whenever I will click around, the application will, whatever I'm using, I usually use Burp for this, it will automatically analyze all of the requests that I am making. Now, automated scanners, they need to be talked over with the client definitely and agreed upon, as they can cause serious damage if they're not used properly. Now, whenever I am hunting, I am on the lookout for any version number that I can find. jQuery versions, database versions, OS versions, anything that's possible. And I will look up these version numbers manually. I'll look up them in Google, and I'll see if there are any vulnerabilities for them. Now, as a developer, you can do things to prevent this. You need to be fully aware of the dependencies that you're using is one of the first things that you need to do. And you need to think over the consequences of each dependency that you are using, because you need to keep all of them up to date. You need to keep all of them registered. It's more than just including another library. Every blind library that you have could be a risk for us. Furthermore, all of these dependencies, if they're entered in an inventory system, they'll give us an easy overview of all of the dependencies that we have, all of those versions that we have, and if one of those versions is out of date by, for example, automatically scanning all of those versions with the latest CVE list that we have available. Now, these scans should all be done periodically and preferably automatically so that they can't be forgotten. These scans are best to be executed by an external system because our customer, whenever this is how the customer faces the web application. So we as a customer, we also come from an external source. All of these automated scanners should take that external source into account. For example, there might be a load balancer in between you and the web server. That's something that also could be vulnerable because it also might have a version number. If we go way too close to the source, we might skip those things like load balancers and the firewalls, but those are also components. Now, all of this needs to be described into a plan which is clear and concise and approved and carried on by everybody in the organization, because yes, updating strategies is something that's very important. Everybody needs to agree upon this because it takes time to keep things updated. Now, as for some examples, to explain the severity of one of these vulnerabilities, we need to look at this from all angles. After all, you want to fix things that are found by your internal scanner. Best practice would have you fix all outdated dependencies, but logic dictates that that's just not true, because fixing all of the dependencies takes a lot of time and a lot of money, and that's something that not every business owner is willing to spend a lot of money upon. So sometimes if there's no real impact, if there's no real issue, why not just keep dependencies outdated if there's no real known vulnerabilities? But of course, we as hackers know better. We as hackers know that outdated components might get vulnerabilities real soon in the future. Outdated components should probably already be updated. One example that I often see in real life target is an outdated version of JavaScript being used or jQuery being used, where cross-site scripting is possible, but that specific function might never ever be used in a complete website, which means that, okay, your specific dependency might be vulnerable, but there is no real impact, and as a bug bounty hunter, this should not be reported. Of course, as a pen tester, you should report this outdated version and hope that the client fixes it. Another example that I can think of is outdated Linux versions. Again, really depend on the exploitability here. If the exploit in question would require us to use a port that was not even open in the first place, there is no real impact, and the reporting of that vulnerability should be held off until we can find some impact. So in short, finding these vulnerabilities should ideally be automated, but one should never overlook the importance of manual audit now and again. As for hackers themselves, I always recommend we judge our impact extremely careful and that we do not report any vulnerability like this in bug bounties until the impact is clear or until we've been able to exploit it properly. For pen testers, it depends, and it's always advised to report at least these things as informative, but ideally they should be exploited as well and looked on further. So thank you very much. That was A9, and we'll see you in the last chapter, A10. Bye, amazing hacker. All right, amazing hackers. The last one we need to talk about is A10 2017, insufficient logging and monitoring. It seems at first sight that this is not really a vulnerability, but more a best practice, but nothing could be further from the truth. If an ongoing attack is not detected in time or even at all, our security measures might be tampered with without us even knowing it. In the event of an attack, we should be informed in a timely manner and with the correct level of detail, of course. This vulnerability type is a particularly nasty one because it's very hard to quantify exactly how much logging and monitoring is required to be safe. Besides being hard to quantify, this is not easy to detect either. The hacker needs to have access to the logging and auditing system, and he needs to be able to see if sensitive topics are being logged properly. He needs to also be able to see if there's no private information being logged, and it should still be possible, though, for any tester to acquire an environment where they can test what is logged as well. Can test several high-profile actions and see if they are logged properly. So you might be wondering, okay, Mr. Rat, what do we then need to log? Well, it's really important to always log at least the following items, but of course you need to use your own imagination a little bit as well. So we need to log any audit event, basically, like logging in, logging out, failed login attempts, high value transactions. All of these things are very important to log. Whenever one of these events occur, we need to have a proper message detailing what the event entailed. And this is often a fine balance between including too much information, which might clog up a logging system, and not including enough information, which might leave you still vulnerable eventually after all. So these logs are very important, but they're useless if nobody checks them. All of these security loggings should be monitored and audited regularly to ensure that no suspicious activity has taken place and that the monitoring has missed. So whenever an event occurs that indicates suspicious activity, there should be an alert sent out as well to keep those responsible informed about any potential attacks ongoing. So what adds an extra layer to complexity, of course, is that the location of these log files should be centralized. We can't store them on the machine itself because currently the applications consist of so many different microservices that it would be impossible to go through each and every single machine and have a look if we can have any issues in the logs. Because there are so many, it's just not doable. All of these logs need to be in a centralized place. And as you can imagine, when a penetration tester or a bug bounty hunter is attacking a corporate network, alarm bells should be ringing off big time. So if no alerts are triggering, we can safely report this as an issue when we are pen testing an application. I said pen testing, not bug bounty hunting, because as bug bounty hunters, we should never have access to the logs, basically. So the logs should not be visible to the end user under any circumstances. They contain valuable information and they should be treated with the same integrity as personal data, in my opinion. You might be wondering how can we prevent this specific vulnerability, and it's really important here that we do a proper risk analysis. We have to ensure that we log all of the details that matter, but also not too much. So what we want to log is any authorization requests, access control failures, server-side input validation failures, high-value transactions should have an audit trail. For example, if you're a bank, somebody withdraws money, you should be able to see which actions led to that person withdrawing your money, like for example, putting in their card, putting in their number, putting in the amount, etc. And we also need to make sure that our logs are not decentralized when they are seeded across many different servers. To achieve that, our logs need to be easily digestible, of course, by a centralized solution, which will allow us to consult and monitor our logs in a timely fashion. An example of this would be Kibana. It's also good to have a plan at hand for when things go wrong and you eventually run into an incident. A good starting point for this would be the link that I've put in the PDF document, which will take you to a document detailing what things should be logged and which ones shouldn't. So it's not very hard to find issues that could arise from insufficient logging and monitoring. An example could be that an attacker could brute force our systems without our knowledge, or that they would attempt to install a backdoor without knowing anything that is sending outgoing and receiving incoming traffic, which should ring off any alarm bells if we have unknown traffic going in and out, of course. All of these things cannot be avoided with logging and monitoring, but they can be caught by them, of course. Thank you very much for listening to number 810. Thank you very much for listening to this entire course. Really, really appreciate it. And I'm really terribly sorry if I sounded a little bit sick. That is because I am a little bit sick. So thank you very much for watching again. I really enjoyed making this course. I learned a ton of stuff from it, and I hope you did too. And I will see you in the next one. Bye, my amazing hacker friend. Much love from Uncle Red. Bye. I will see you later.